Okay, here are the different types of simple machines, and you only need to know 3 of them for the exam. So you need to know how the lever works, you need to know how the pulley works, and you need to know how the inclined plane works. You need to know the definition of a simple machine. So what does a simple machine do? Please do not say that it increases your energy. Okay, it can't do that because of the first law of thermodynamics. As a matter of fact, a simple machine is actually going to give off less energy than you put into it because of the second law of thermodynamics. So it does not make work any easier, nor does it increase your energy. But what it can increase is force, or it can increase distance. Not both at the same time. So if it increases your force, it will decrease the distance. If it decreases the force, it will increase the distance. But all simple machines are going to work the same way. You're going to put a certain amount of work into a machine, which is going to be a force times a distance, and then what's going to come out is going to be more work, a force times a distance. And you're not going to need to worry about the efficiency of the machine. So let's look at the different kinds of machines. So the first machine is going to be the lever. And the only kind of lever that you need to know for the exam is going to be the teeter-totter, which is a first-class lever. So this is the only one that you're going to need to worry about. And you're going to put in a certain amount of force on this side, and it's going to be a distance r from the fulcrum. So this is going to be r in. And then it's going to lift a box or something over on this side, and this box is going to have a certain weight. And so when you push on this side, it's going to lift it up on this side over here. And then it also has a certain r out on this side. So that's going to be the distance from the fulcrum to here. I will give you 3 of the letters, and then you solve it for the 4th one. So here's an example of how you might do one of these problems. Work in equals work out. And then don't forget to put the Newton on the end of the number, because newtons is a unit of force. Okay, then you had the simple machine. Now the key to doing the simple machine is to count the number of strings that's holding up the weight. So if we had a machine over here, okay, a rope comes up, it goes around here, it goes down here, comes up here, and let's say it connects to right there. How many strings are holding up the weight? So the weight is over here, and we want to know how many ropes is holding it up. It's not 3, it's 2. So you've got this rope, and then you got this rope. Okay, so let's say that this is 10 newtons. Then that means that each rope is pulling with 5 newtons. So 5 plus 5 makes 10. So 5 newtons and 5 newtons makes 10 newtons. So that means if you pull on this string, then you only need to pull with 5 newtons, and you'll be able to lift 10 newtons. But you can't get something for nothing. So what's going to happen is, let's say that you want to lift this thing up 10 centimeters. You're going to have to pull with twice the distance. So you're going to have to pull 20 centimeters in order to raise this thing only 10 centimeters. So notice the force that you're applying is 5, multiplied by the distance, so that would be 100 Newton centimeters. Let's look over here. The force is going to be 10 newtons, but the distance is going to be 10. So 10 times 10 is 100. So notice the energy that is going into the pulley is the same as the energy that's coming out of the pulley. And in actuality, it would turn out that you would need to pull with more than 5 newtons of force, because some of the energy would be wasted in the form of heat. But on the exam, don't worry about that. So here's an example of how to use these concepts to solve a pulley problem. Okay, then now we're going to do the ramp. So you're going to need to be able to do a lever, and then a pulley, and then a ramp. So with a ramp, you're going to have a ramp that has a certain length, L. So this length, L, is this distance here. And then it's going to, you're going to have a box or something. You're going to push on the box with a certain force, and this is the force that goes into the box. And then it's going to push the box up to here. So this is where the box ends up. Well, you could have taken the box and you could have lifted it straight up into the air until it was up here. So notice there's 2 different ways of getting the box up there. This force times this length, or this force, which is equal to the weight, which is pulling down, multiplied by this distance. So this is going to be the rise, this distance right here. So the amount of energy that goes into this one is the same as the energy it took to lift it straight up into the air. But in actuality, it would turn out that you would need to push with more force, because some of the energy is being turned into heat due to friction. So here's an example of a problem that you ought to be able to do on the exam. So that's it. So that is the review for the chapter on energy. So stay tuned, and we will do another lesson that you will need to know for the Unit 4 lecture exam.